cheese. No, I press up, forwards.
Down.
Whichever one you're doing, it's the other one.
Right. I like the way, Steve, you moved the mic down. Thank you. So, I'm here to talk about the science of sugar this time, which it turns out when you say you're doing that, people go, why are you doing that? I will explain why, but not until I've handed out a few samples, which are carefully packaged so I don't throw them at people. So I have a few bags. It'd be nice if they could work their way around to be spread out.
Are we supposed to eat? Can we eat them?
There are carefully measured things in there. You've got 3 bags, if you can pass them backwards. If you are able to not eat them for a while, there'll be a reward in it for you. But pass them back so you've kind of got them in groups. Keep one near the front here, come on. All right, so it's down. So, yeah, as Steve said, previously on Science Showoff we did the science of cheese. This kind of happened by, well, it was a long story, meeting a girl in a bar over drinks, and I ended up promising to talk, and I didn't know what to talk about, so I asked Twitter what to talk about, and Twitter said cheese. At which point I realised I knew bugger all about cheese, so I'd better do some experiments and go back to real basics. So I dug out my kids' Key Stage 2 primary school science textbook, and I thought I'd do some basic experiments, like, does it float or sink? One of the first experiments you do in school, right? Does it conduct electricity? Does it burn? Is it solid or liquid? And so I did all these little experiments, and I prepared a nice little presentation, and before I gave the results one by one to the audience, I actually asked what people thought, does it float or sink? What I learned, the actual big conclusion, was that people eat a lot of stuff without any freaking idea what it is. So I thought, I need to go on a bit of a mission here, which is to apply a similar rigorous testing methodology to all the major food groups. So I'm doing sugar today, and next, if Steve will ever let me back, I think we'll do chocolate, and then bread, and then, of course, alcohol. And if anyone has any other important food groups, come and see me. I'm a bit lost, I'm not a biologist. So, experiment 1 is sugar a solid or a liquid? First experiment. Obvious. But we can look a bit further, right? Sugar has a crystal structure. And have you ever wondered why things are brown? So in primary school, the other thing, you do a lot of art, right? You wonder, every time you mix loads of colours together, it all turns out brown. I think I know why. If you have the right technique, you can reveal the proper crystal packing structure. I haven't got the right techniques, but I reckon that's what's going on. Second question, does sugar float or sink? All right, sugar cubes, cup of tea, done it. Right, moving on, right, they don't do this at primary school, but does it burn? I wasted a fuck of a lot of time with cheese. Didn't want to waste time with sugar. Turns out sugar does, it carries on going like that for quite a while, and in fact it's explosive if you get it wrong. So that's a sugar factory in the US that blew up in 2008, so icing sugar, it goes everywhere. There's a lot of corn flour in it, which makes it worse. So, 4, does it conduct electricity? That's my electronics lab I took it to. That's wired up without the sugar cube in it. Turns out, no. Cheese does, though. So, sugar actually, besides those boring things, it has a load of really interesting properties, right? It's sweet, that's why we like it. It's sticky, it's actually used in loads of glues. It's noisy. If you have time after this, go to YouTube and look up Screaming Jelly Baby. It's freaking awesome. You can keep time with it. It's various forms of sugar of lubricant. I've heard of different sugars being used in deep-sea oil drilling to stop the stuff from clogging up. It's luminescent. If you ever got home at night and you've got some post, and like in my house, it's a few steps to the light switch, and I'm opening my post, and you get these strange blue flashes as you break the bonds in the glue that's made of sugar. The other thing you can do is if you ever out late at night and it's dark, if you carry a pack of polos and a pair of pliers, cracking polos with pliers actually gives off a little blue light. Try it one night when it's really dark. It also scares off unwanted suitors. Maybe that's the polos with their minty taste, or maybe it's the pliers, I don't know. Oh yeah, forgot to mention, it's also a medicinal catalyst. A spoonful of sugar helps the medicine go down, right? This stuff artificial sweeteners. The story of how some of these were found is quite amazing. This stuff, there was a lab in 1978 that were researching, sugar's got all sorts of interesting properties. They were playing with sucrose chemically, making derivatives of sucrose, to see whether any of the results, they were making all sorts of stuff, whether any of the results did anything useful. One day, the supervisor, they'd made a bunch of stuff, and the supervisor gave to one of his juniors, a chap called Fadness, he gave a bunch of samples, and he said, take these and test them. Fadness came back the next morning and said, I've tasted them, this one's sweet. No idea what it is, and he's just shoved all of it in his mouth. What was my point? In the 1840s, I think it was, there was a chap making coal tar derivative chemicals and trying to come up with interesting uses for those, and he went out for dinner and he had a bread roll, and his bread roll tasted ridiculously sweet. Later on, he wipes his moustache with his napkin, and he found this, his words, he's discovered this singular source of sweetness, universal source of sweetness. So he rushes back to the lab to taste everything he made that day, putting any old shit in his mouth. A really boring definition. Some sugars, like 1 of your 5 a day. Not sugar. That's what's left when you've taken all the good stuff out of cane sugar. Well, there's a bit of sucrose left in it. So let's get on to chemistry. Let's actually learn something. Chemistry. Glucose. Looks like that. I made one. So one of my hydrogens fell out on the way here. I tried to replace it with a polo, but... people kept coming up and grabbing it. So that's glucose. It's a hexagon, right? These are all carbon atoms, but you've got an oxygen atom in the middle. They've all got the same, this and fructose, which is basically the same thing, but it's a pentagon. One of the carbons is outside the ring. And, of course, they're quite sweet, but they're so sweet they hold hands and make something even sweeter, which is glucose. There are more sugars. This one is the Santa Claus of sugars. This one is a bastard and really intolerant. There is expensive sugar. And there is Haribo's. They're all ending in O's, of course. Everything ending in O's is a sugar. So this is the group exercise point. So you've got in your bags the exact right stuff to make glucose. So who's eaten some? No one has eaten any of the marshmallows? Awesome. Because this is the basis of the Stanford marshmallow experiment, where children were given a marshmallow and told, I'm going to leave the room, but if the marshmallow's still there in 15 minutes, you can have 2. So they then followed up with these people and checked out their SATs later on. And they found that children who were able to wait longer for a reward tended to have better life outcomes. So well done, all of you! You can now eat the sugar. Marshmallows are not vegetarian. I checked out the matchmakers and I believe they are. So let's do... Sorry? You can make it. We haven't got time, look. I tried this. It takes ages. We will close with a little biology. So this stuff looks familiar, right? It's a pentagon again. This is called ribose. If you knock off, with a little bit of Photoshop, one of these OHs, makes a real thing, which is called deoxyribose. You might start to think of something familiar now. This is something. These hexagons, there, and there, and there, and there, and all the way around are these hexagons of a pentagon, and the green bits are carbon, and the red bits are oxygen, and things hanging off are these OH groups. So that is deoxyribose, held together by little phosphate bonds. So the backbone of DNA is deoxyribose. The backbone of DNA is a sugar. So physicists like to say we're all made of stardust. I like to remember that we're all made of sugar.